a revision for what we have learned before the holiday, okay, before the term break. We're up to 6F, which is graph the polynomials. Okay, there must be one question related to graphing. Okay, related to graphing. So how do we graph polynomials? Normally, I will only give you questions like cubic. Okay, because we haven't tested on quartic at all, so we'll only learn cubic. So how to graph cubic? So I said it's like long essay. I will leave it to you to read it if you forget how to graph it. But generally, if we want to graph this, we need to factorize first. Okay, we need to factorize first. Factorize to the possible like 3 linears. Okay, 3 linears. So that's 3 linear, x plus 1, x plus 3, and x minus 2. And we can find the x-intercept. How do we find x-intercept? We'll use fx equals to 0. And then we can find by using the non-factor law, we can have x equals to minus 1, x equals to minus 3, and x equals to 2. And I can label 3 points on the x-axis. And then we can find the y-x-axis, which use the general equation here, when x equals to 0, y equals to minus 6. So we have minus 6 here. And then the next thing we need to think about is whether we should start to graph on the right top or right bottom. So if the leading term has a positive coefficient, we will start from the right top to start our graph. So you can go through every single hole. Okay, so you have a graph like that. So start from the right top, so go through the first hole and then the next one and back and turning back. We don't have any holes back here, so the graph will turn up again. So, and another thing is, the turning point doesn't exist between the two x-intercepts, in the middle of the two x-intercepts. It doesn't exist in the middle. So, and also, maybe it's not the y-intercept. So, try to show your turning point somewhere not in the middle, not on the y-intercept. Okay, so I don't care where is it. We can learn this in maybe end of this term or start of next term. So we need to show it not in the middle and not on the y-intercept. Okay, so that's everything about, you have 3 distinct linear factors. And we have example 2. So example 2, we still need to factorize it. Okay, how do we factorize? We use this table to factorize. We try a value and we want to see 0. Okay, so what's the number I need to try? I need to try the coefficient for the leading term, which is 1. So you have plus minus 1. And also the coefficient for, the factors for the constant term, you have 2. So you have plus minus 1 and plus minus 2. 4 number wants you to try plus minus 1 and plus minus 2. And we try minus 1 gives me 0. So I'll have x plus 1, x squared minus x minus 2, and further factorize this quadratic because I can factorize this. So we can see we have 2 repeated terms. Okay, if you have an even number of repeated terms, okay, an even number of repeated terms, that will become a turning point. Okay, if the x-intercept, you have 3, okay, you have 3 linear factor which repeats 3 times, that will become a point of inflection, which we'll learn in the quartic, okay, in the next exercise. So if repeat twice or even number of times, for example, twice or 4 times or 6 times, that all become a turning point. If it repeats 3 times, 5 times, and 7 times, and so on, it will become a point of inflection at that x-intercept. So we have x plus 1 twice. So minus 1 will become the turning point. Okay, minus 1 will become the turning point. Also, I have another point at 2. So you have this point here. And I can see the y-intercept will be negative 2, which is here. And I'll see the leading term, which is positive. Positive leading terms start from the top right. And it goes through every hole. And remember, that's the turning point. So it not goes through this hole, you will turn down here. Okay, that's the turning point. So it touches this x-intercept and going down. Okay, so that's for the second case. We have repeated factors for cubic. So let's have a look at the third case. Okay, example 3. Cubic with only 1 x-intercept. Okay, cubic with only 1 x-intercept. So we have minus x cubed minus 3x squared minus x plus 5. So what I will try is plus minus 1 and plus minus 1 plus minus 5. Okay, that's what I'm going to try. I will set up this table first. Okay, I have coefficient -1, coefficient -3, coefficient -1, and constant 5. Okay, 4 numbers in the order, okay, in the decreasing order. Cubic, quadratic, linear, and constant, okay, in this decreasing order. Okay, the number I may try is, maybe let's try 1. Okay, if I try 1, that gives me negative, the first term always come down with -1, and I'll times the 1 with the -1, give me -1, and go to add the next number, which is -1 plus -3, give me -4. And 1 will times the -4, give me -4, -4 plus -1 gives me -5. 1 times -5 give me -5, -5 go to plus the 5, which gives me a 0. Okay, which gives me a 0. So fx will equals to, okay, 1 is the factor. Okay, 1 is a number can make fx equals to 0. So that will be x minus 1. Okay, x minus that number. And I have minus x squared minus 4x and minus 5. Okay, I have all the minus. So what I can do, I put the minus in the front. It's not necessary to do that, but I think if you take the negative, it can looks better. So it's all positive numbers. And the next thing is, I'm going to factorize this. Okay, I'm going to factorize this quadratic. And remember, before you factorize the quadratic, unless you can really see it easily, okay, I can factorize it because I can use the what is called perfect square, or I can see it's a cross multiplication. I can have a factor easily. Otherwise, I need to test the discriminant first, because some quadratic cannot be factorized. So don't waste your time. Track the discriminant. I have 16 minus 1, 4 times 1 times 5, which is times together is 20. So 16 minus 20 give you a negative number. Your discriminant is actually smaller than 0. What that means? That means there's no further factorization for that quadratic term. Okay, so I finished my factorization, but it's not a fully factorized cubic. Okay, it's not a fully factorized cubic. Fully factorized means you must have all linear terms. But for this one, I stop as a quadratic. I can't further factorize it. So I will stop here. It's a not fully factorized term. Okay, so what that means, I will still find the x-intercept. So when fx equals to 0, you will have that equals to 0. So it's either x minus 1 equals to 0 or x squared plus 4x plus 5 equals to 0. But for this one, you will have no solution. The reason is my discriminant is smaller than 0. I can't use the quadratic formula because it's square root of a negative number. So I have no solution for that one. So I only have one x-intercept, which is x equals to 1. Okay, cubic, you can have one x-intercept, which is x equals to 1. And when x equals to 0, my fx equals to positive 5. So you have 0, 5, and for this one you have 1, 0. Okay. And let's sketch this one. Have y, have x, and you have 0, 5, which is here. Have 1, 0, which is here. Okay, so let's not label it first. Where I should start this graph? Where I should start? Bottom. Okay, right bottom. Because the leading term is minus x cubed. Leading term is minus x cubed. So it's a negative coefficient. I should start from the right bottom. Okay, if you start from the right bottom, here. Okay, let's say here, somewhere around here. So this graph should go through this point and go through that point. Okay, my question is, where this graph should go after this point? I can't going down, right? I can't going down because I don't have any x-intercept. If I'm going down, there must be an intercept in the x-intercept here. But I don't have any x-intercept. I don't have any other holes on this graph. I can't go bottom, but I can't keep going up. Like, it's not a cubic shape. So what is a normal cubic shape? A normal cubic shape will be like this or like this. That's a normal cubic shape. So if you don't have the calculator, you can't really sketch this graph like really on the scale, but I will have roughly that shape. Okay, I have roughly like the top shape because it's a negative. So start from the bottom. So I should have another turning point somewhere in the middle. Okay, I should maintain this shape. See all your cubic. Okay, see this cubic looks like that. This cubic looks like that. You all have two turning points somewhere. So we can say we have a turning point somewhere here and turning back. Okay, I don't know where I should turn. Okay, I don't know exactly where I should turn for those 2 points. But to maintain this shape, you will turn somewhere around here. Or you can turn like later, like a bigger graph like that. But the shape will like be like that. Why I don't have here? Because there's no x-intercept. The turning point must be in the middle there. Okay, I can't go down here. So I can turn a little bit like that. Can turn even like that. Okay, just give me the shape. I don't really worry about where is the turning point. Just give me the shape. Okay, it should turn above the x-axis. Okay, above the x-axis. Just remember, if it's a cubic, it either got this shape, okay, or this shape, which is the ax minus h cubed plus k. You have point of stationary point of inflection, which goes to shape. But for this question, you don't have this standard formula. Okay, it's not in the term of ax minus h cubed plus k. So it must follow those two shapes. Okay, it must follow those two shapes. You have two turning points. Therefore, after you complete connect those two holes together, you know you will have another two turning point, which the graph will look like that. Does that make sense? It's a little bit like difficult because you don't know where it's exactly to turn, but don't need to worry about that. Just turn somewhere. And I need to label 0, 5, and I need to label 1, 0. Okay, I'll put this here. Okay, any questions regarding to sketching the graph? Okay, if you don't have any questions, let's have a look at 6G, which is solving cubic inequalities. Okay, solving cubic inequalities. One question is, do you remember how to solve quadratic inequalities? How do we solve for that? Draw the graph. Okay, good. Draw the graph. So anything other than linear inequality, you all need this graph to see how to solve the inequalities. So same thing here. Let's have a look at this question. You have x cubed. You want to solve. Okay. First, you need to understand the set notation. I want to have a set, a collection of x, such that x cubed plus x squared minus 5x plus 3 needs to be less than or equals to 0. Okay, so it's a set. So it's a collection of x terms, such that your x needs to satisfy this following condition. So basically, it's asking you to solve this inequality. So how do we solve for this inequality? Okay, so we have x cubed plus x squared minus 5x plus 3 needs to be less than or equals to 0. First of all, your right hand side always needs to be 0. Okay, you always need to solve something less or greater than 0. The next thing is you need to sketch this graph. Let's say this graph is, let's say that's y. Let's make y equals to x cubed plus x squared minus 5x plus 3. Let y equals to that. Therefore, I can sketch for it. So the next thing is I need to solve y less than or equals to 0. And I need to sketch for it. So to sketch cubic, what I need to do first? Factorize, okay, factorize. So how do we factorize? We will see the number I should try to give your y equals to 0. So I will try plus minus 1 or plus minus 3. Okay, plus minus 1 or plus minus 3. You can quite see 1 is answer. Okay, you can see 1 is the answer. 1 plus 1 minus 5 plus 3 obviously is the answer. But I want to see the other factors. Okay, 1, 1 minus 5 and 3. And I will try 1. 1 times 1 is 1. 1 plus 1 give you 2. 1 times 2 minus 5 give me minus 3. 1 times minus 3 plus the 3 give me 0. So y equals to x minus the number you try, and you have x squared plus 2x minus 3. Y equals to x minus 1. Okay, 1 and negative 3 want to make a 2. So 1, 1, 3 and 1 is a minus 3, and I need a positive 2. That number needs to be negative, so it's negative 1 plus 3 give me 2. So I have x minus 1 and x plus 3. Okay, really easy to see by cross multiplication. I can factorize this quadratic. I don't need to try the discriminant. Or if you can't see, you can try the discriminant first. And y equals to x minus 1 squared. You have 2x minus 1. And you have x plus 3. And the next thing you will do is y. Okay, when y equals to 0, because you want to sketch for it, when y equals to 0, x equals to 1, 1, and minus 3 by using the non-factor law. Okay, you have 2 ones. Okay, remember 2 factors give you 2 solutions. Even though it's repeated, like maybe better to list it out. And you know that will become a turning point. You have 2 twice. Okay, have that factor twice. So you have that. And when x equals to 0, y will give you positive 3. Okay, from the general equation, the constant is 3. So give you positive 3. And the next thing is to sketch for this. Have x and y. Okay, you have 0, 3 is the y-intercept. And you have 1. Okay, remember 1 is a turning point. Okay, if you forgetting that, that will be really bad. You need to label turning point here, okay? To tell yourself that's a turning point. And minus 3. Okay, that's a normal intercept. The graph will go through that point. Okay, the next thing is to decide where to start to sketch this graph. Okay, the leading term is x plus x cubed, positive x cubed. So start from the top right. Okay, start from the top right. Let's say we start here. Go to that hole, but you won't go through that. That will become a turning point. So go to the next hole. And go to the next one. And you'll finish your graph. That is minus 3, 0. That point is 1, 0. And that is 0, 3. The turning point might not be at the correct position. Okay, the turning point may not be at the correct position. Okay, it's normally not at the correct position. You don't know where is it. But like, I just put it there. And the next thing is to decide to solve this inequality. Okay, to decide where I should, like which part is the correct part. What I need I need y smaller or equals to 0. Okay, smaller or equals to 0. You want to see what kind of x can give you y less than or equals to 0. Okay, so you just see which part is below the x-axis or on the x-axis. So this part of the graph is below the x-axis and include this point. Okay, include this point. Is there any point satisfy or any part of the graph satisfy y less than or equals to 0? No. What is that? There's another point, 1. Can you see 1? 1 is on the x-axis. Okay, 1 is on the x-axis. Can you see that equals to 0? Okay, that equals to 0. That point also satisfies. Don't forget, you can have less than or equals to 0. It's not only the part of the graph below the x-axis, also the part of the graph on the x-axis. So 1 is definitely this point. Okay, and the next thing you see, that's the y satisfied already, okay, below the x-axis or on the x-axis. Then you see what kind of x can give those graphs. Okay, what part of x corresponding to those part of the graph. Okay, if you draw the vertical line, can you see is that bit of the x value. Include that point and also include that point. So how you can describe those x in this set notation? Okay, how do you describe those x in this set notation? Because it's asked you in the set, okay, it's a set of collection of x such that x satisfies this condition. You need to write your answer in set notation as well. So you will write x belongs to, okay, set notation, x belongs to a set. Belongs to which set? From negative infinity to the point -3, you need to include -3. Okay, -3 is the solution. Union, another point. You want to only union one point, not a set of numbers. Okay, only the point x equals to 1. So you use this curly bracket and you put 1 in, which means I union one single point. Okay, it's a set negative infinity to -3, union the single point 1. Okay, so that is the most correct answer. Okay, that's the most correct answer. Okay, so that should be your final solution. All of the things above is your working steps. Okay, so working steps. So that is your answer. Okay, any questions? I only put one example here because we have learned how to solve quadratics, and I think you know how to solve quadratic inequality. For cubic inequality, you just need to know how to sketch the graph and choose the correct part. Okay. Okay, go a little bit more. 6H. Families of cubic polynomials and functions. Okay, let's have a look at this. Okay, let's have a look at this. Do you remember at the beginning of the term, the first semester, we learned the family of linear and also the family of quadratic. Okay, remember that? Okay, family of linear. So what kind of graph can be family of linear? So they either share the same common point or they share the same gradient. They have something in common. I can say, oh, they all have the same gradient, or they all pass through the same point. Okay, so we can have that. And for quadratic, okay, for quadratic, we can have more things. They can share two same x-intercepts, or they have the same A values, or they have the same B values, or they have the same y-intercept. There's more things we can talk about. Okay, so just give you some examples. You don't need to really tell me how many types can be the family of graph. You just need to tell me, give you one equation and what's the thing shared in common. Let's have a look at the first one. If we have y equals to ax cubed, the A value can vary, but they all share a same point, which is 0, 0. which is the stationary point of inflection. So I will say I will have stationary point of inflection at 0, 0 for all this graph. Okay, for all this graph. Stationary point of inflection at 0, 0. Okay, they all share the same stationary point of inflection. For the second one, if h and k are the fixed value, a is a number can vary. So I will say it will share the same point of inflection at h, k. Okay, they have the same shape. They all maybe not the same shape. They can dilate, but they all pass through the same point h, k. Okay, for the next one, if capital A, B, C are the fixed number and still the lowercase a is a number can vary, what will be the common feature? Capital A, B, C is a number, like a fixed number, it won't change. What will be the common feature? X-intercept. Okay, x-intercept. When y equals to 0, doesn't matter with this a value, you will always have capital A, 0, capital B, 0, capital C, 0. So they will have the same x-intercepts at A, 0, B, 0, and C, 0. Okay, for the next one, y equals to ax cubed plus bx squared plus cx. A, B, C all can vary. So what will be a common thing here? A, B, C can all change. What will be a common thing here? What, like, for a cubic, I should have 4 terms, right? X cubed, x squared, x, and constant. Do we have constant here? No constant. No constant means what? If x equals to 0, what y equals to? 0. 0. Okay, always be 0. If x equals to 0, y will always be 0, which means it always pass through the origin. Okay. It will always pass through the origin, which is 0, 0. Like A, B, C can change, the shape can change. There will be 1 x-intercept only, or there will be 2 x-intercept or 3 x-intercept, but doesn't matter. It will always pass through the point 0, 0 because there's no constant term. If a polynomial has no constant term, which means it must pass through the point 0, 0. Okay, if this polynomial has no constant term, it means it must pass through the point 0, 0. So the question, and not really like have a lot of this type of question in the VCA exam, but like the only possibility to ask you this is what's the common thing? Okay, what's the common feature for this type of family of graphs? Okay, for this family polynomials, what is the things in common you can see? So you just need to describe things like what I write here. They all have the same stationary point of inflection, or they all have the same x-intercept, or not necessary to be a key feature point. It just say pass through one single point. They all pass through one single point. Okay. Let's have a look at the next question. Find the equations for the given cubic. Okay, find the equations for the given cubic. It will be the same as find the equations for linear, find the equations for quadratic, find the equations for cubic. They're all the same thing. You only need to do is substitution. Or find the key feature point, write the equations, find the unknowns. Okay, so it's all the same. A cubic function has rule of the fx equals to ax cubed plus bx. Okay, don't have x squared term, don't have the constant term. The point 1, 16 and 2, 30 are on the graph. So find the values of a and b. So when x equals to 1, fx will equals to 16. When x equals to 2, fx will equals to 30. That's the information you know. So what you can do is 16 equals to a times 1 cubed plus b times 1. 30 equals to a times 2 cubed plus b times 2. So you have a plus b equals to 16. And you have 8a plus 2b equals to 30. I can times equation 1. Let's say that's equation 1, that's equation 2. I can times equation 1 by 2 to make the same number of b terms, and I can do the elimination. Okay, that's solving two linear simultaneous equations. So 2a plus 2b equals to 32. Okay, 2a plus 2b equals to 32. What I need to do is subtract between the two equations. I'll just subtract the top one from the bottom one. 2a minus 8a give me minus 6a. 2b minus 2b equals to 0. 32 minus 30 gives me 2. So a will be negative 1/3. A will be negative 1/3. Okay, 16 equals to a plus b, and 30 equals to 8a plus 2b, and you times equation 1 by 2. 2a plus 2b gives you 32. 32 minus 30 gives you 2. 2a minus 6a gives you negative 6a. So divide by that, you have negative 1/3. Okay, when a equals to negative 1/3, negative 1/3 plus b equals to 16. b will equals to 48/3 plus 1/3. b will be 49/3. Therefore, fx equals to negative 1/3 x cubed plus 49/3 x. Okay, if I factorize this one, I will put negative 1/3 out, and I take x. I have x squared minus 49. And x minus 49, that will give me x plus 7 and x minus 7. Okay, so 8. Okay, you don't really need to factorize. Okay, actually in the exam, do not factorize. Okay, do not factorize unless it asks you to do so, because you can make mistakes when you factorize it and you lose mark. If you do something, for example, the question doesn't ask you to factorize and you factorize, if it's correct, you will get the mark. If you factorize it and it's wrong, you won't get the mark. You won't get the answer mark because you have a wrong answer in the end. So unless it asks you to do so, otherwise do not factorize. Okay, do not do anything extra. Okay, do not do anything extra. Okay, the next one. The question is not really clear. Let's say that point is -1 and 2. And I will tell you that's a stationary point of inflection. Okay, -1 and 2 is a stationary point of inflection. And also pass through the point 1, -2. Okay, also pass through the point 1, -2. So what I should start? Which I should start with? Which equation I should start with? Which type of standard form or like factorized form, or what kind of form I should start with? I have two types of cubic function. Okay, I have two types of cubic function. One type looks like that, have stationary point of inflection. The other type will be like the curve. Okay, that one. That is the factorized form. Okay, either start with the point of inflection form or start with the fully factorized form. So which one I should choose for this one? Stationary point of inflection form. Okay, so you have stationary point of inflection at -1 and 2, which means if you h equals to -1 and k is 2. Okay, h comma k, right, is the stationary point of inflection. So what's the stationary point of inflection form? Is a times x minus h cubed plus k. Because only this type of formula can give you this shape. Okay, the fully factorized form will not give you this shape. Will only be this shape. So h equals to -1 and k is 2. Therefore, I can write y equals, do not assume a is 1. A may not be 1. So x minus -1 will be x plus 1 cubed plus 2. The only unknown is the a value. Okay, the only unknown is the a value. So for a quadratic, let's say you have 2 x-intercept and you write the x-intercept for, you still need to find the a value. The thing we do is we substitute another point in and to find the a value. Therefore, I need to substitute when x equals to 1, y equals to -2. So -2 equals to a times 1 plus 1 is 2, 2 cubed plus 2. Okay, subtract the 2, -4 equals to 8a. A will be -1/2. And you need to restate the rule. Y is -1/2. See, a is not 1. So x plus 1 cubed plus 2. Okay, that is what we have. Okay, you don't need to expand. Again, you don't need to expand. That's a cubic function and it's good enough to be the answer. Okay, don't need to expand. Okay, any questions about those two questions? I need to draw a line here. Let's get the second one. Okay. Okay, let's have a look at this. Okay, I'll only go through this one. That's the last one. Example 4, I will leave you to do this. Okay, example 3. Example 3. That's not the point of inflection shape. Okay, it's not the point of inflection shape. You can see there are 2 turning points. It must be in the fully factorized form. Okay, it must be in the fully factorized form. Okay, so the key thing we will look at is the intercept. That's 2, 0, and that is -1, 0. Okay, so what I will do is and also you can see at the point 2, you have a turning point. Okay, that's a turning point. If that's a turning point, you have 2 repeated factor for that point. Okay, you have 2 repeated factor for that point. Okay, I will start to write this equation as y equals to, okay, you have one single factor at -1. Then is x minus that x-intercept, which gives you x plus 1. Okay, you want to see x plus 1 equals to 0. That will give you x equals to -1. So you need to minus the x-intercept. The next one is 2. You have x minus 2. And that's a repeated factor. You will have 2 of that term, so it's squared. Have we done? Do you think it's the final answer? No. You need to have what? A value. Okay, good. You need to always have this A value. You don't know the stretch, okay? You don't need the dilation. So you need to work out the dilation factor A. Okay. One thing is what the other point you use. Which point you use on this graph? You need to substitute 3, 2. Can we use 0, 2? is, you don't know whether it's really onto or not. There's no point really tells you that passes through 0, 2. For this question, yes, finally we work out it passed through 0, 2. But do not take the risk, it might not be passing through that point. It may be a 0.1 difference between the graph and the actual value. Okay, it can be passed through the 0,1.99. Okay, maybe not necessary to be 2. So do not use a point which have a label for you. So use the point 3, 2 instead. Use the point 3, 2 instead. So when x equals to 3, y equals to 2. So 2 equals to a bracket 3 plus 1, 3 minus 2 squared. 2 equals to a times 4 times 3 minus 2 gives you 1, 1 squared gives you 1. So a equals to 2 divided by 4, which is a half. Which is a half. So y equals to a half x plus 1, x minus 2 squared. Do not expand, leave your answer like that. That's good enough. And also you can check your answer, like roughly check your answer. How do you check your answer? You can see a is the coefficient for the highest leading term, right? And the graph starts from the right top. You need to have a positive number. If you solve out your a is a negative number, which means something wrong. Okay, which means something wrong. It must be a positive number. So a equals to half is a reasonable answer. Okay, roughly check it. Okay, that's finding equations for like some fx. You can have the description. You can have a graph. Okay, they're all in the easy type. Have a look at your homework will be example 4. Try to do example 4 before the next lesson, okay? You have 1 day to do it, do example 4.